Quadratics, the square root property. Remember, the quadratic equation is an equation of the form ax squared plus bx plus c equals 0. Let's look at an example. Say we have x squared equals 9. Well, we know this is quadratic because it has an x squared, but it needs to equal 0, so we need to subtract 9 on both sides. From here, this should look familiar, and what we try to use is we try to factor. Take a moment now to factor this quadratic. Hopefully you found one of the binomials to be x plus 3 and the other to be x minus 3. Now that it's written in this form, that means we have some number times some number equals 0, and so now we need to solve for x. We take the first value, x plus 3, set it equal to 0, and isolate x by subtracting 3 on both sides, and we find x equals negative 3. Now there's another possibility, and that'd be the other binomial of x minus 3 equals 0. Again, we isolate x by adding 3 to both sides, and we find x equals 3. In this case, we had two possible solutions. Now, not all quadratic equations can be solved by factoring. Let's explore. Look back at the solutions of x squared equals 9. We found x to equal negative 3 and x to equal positive 3. Let's check these. If I plug in a negative 3 in for the original equation, negative 3 squared does equal 9, which means 9 equals 9, and that's true, so it works. Let's check the other solution. I plug in a positive 3, 3 squared does equal 9, and 9 equals 9 is a true statement. It also works. Now in math, there are usually two operations that work together. Addition works with what? Subtraction. Multiplication works with what? Division. Squaring something works with what? Do you know? Well, squaring something works with square root. So, let's look back at our original equation. Notice we have x squared equals 9. Well, x squared, we want to undo that operation. So what operation works with squaring something? Well, square root. So what we're going to do is we take the original equation and we are going to take the square root of the left side and the right side. The whole purpose is to get x by itself. But as it stands, x squared means some number times itself gives me a 9. And it turns out there's actually two possibilities. So we have to include the positive and the negative version. So I include this plus or minus sign. On the left side of the equation, the square root and the square undo each other, giving you x equals, and then we have the plus or minus, and we factor the 9 to be 3 times 3. Since we did bring in a radical, we want to pull out any sets if possible, and notice we do have a set of 3's, so your answer is x equals positive or negative 3, which agrees with our solutions we found earlier. So that brings us to what's known as the square root property. The square root property states, if a squared equals b, then a equals plus or minus square root of b. Now, what does that really mean? Well, if you look at the a squared, that means if something squared equals something. If you have something squared equals something, Then you are allowed to take the square root of both sides of the equation. Let's look at an example. Example 1 says solve, and for A we have the equation 5x squared minus 55 equals 0. Now this is an equation, so draw your line at the equal sign. And notice, the only variable we see is x squared, so we do want to isolate it. So first we need to add 55 on both sides. From here, we still need to get x squared by itself, so we have to undo multiplication, which means we're going to divide the left side and the right side by 5, which now gives us x squared equals 11. Notice we now have something squared equals something, which means we're now ready to use the square root property. So what we do is we take the square root of the left side and the square root of the right side, but don't forget plus or minus. So the square root and the square undo each other, giving you x equals plus or minus square root of 11. Now we want to simplify the radical if possible. Can 11 factor? No. So we cannot simplify the radical, but now we need to see what our answers really are. That plus and minus means we have two possibilities. Let's explore that. If I look at the plus version, that means x equals a positive square root 11. Next I look at the minus, which would give me x equals a negative square root 11. Neither of these answers can be reduced or simplified, so those are your solutions. B. We have x plus 2 quantity squared equals 18. First, draw your line at your equal sign. Now, notice the way this is written. Do we have something squared equals something? Well, it appears so, which means we can use the square root property. So looking at the left side, we are going to take the square root. On the right side, we are going to take the square root, but don't forget about the plus or minus. So the square and the square root on the left side undo each other, giving you x plus 2 equals plus or minus the square root of 18. Since we have introduced a radical, we do need to simplify. So take a moment now to factor 18. Hopefully you found for the factors of 18 to be 2, 3, and 3. Notice we do have a set of 3's under the radical, and whenever you pull it out, it always goes immediately in front of the radical. So now we have x plus 2 equals plus or minus 3 square root 2. We are still on a mission to solve for x, which means we need to isolate the variable. Since we have x plus 2, to undo addition, we need to do what? Subtract. So we do subtract 2 on the left side, as long as we subtract 2 on the right side, but it must go in front. And so that leaves us with x equals negative 2 plus or minus 3 square root 2. Since we have the plus or minus sign, we do need to separate. Looking at the plus version, that gives us x equals negative 2 plus 3 square root 2. Can we combine those two terms? No. The negative 2 is a constant, while 3 square root 2 is a radical, so these are not like terms. Now let's look at the minus version. That would give us x equals negative 2 minus 3 square root 2, and these both would be your solution. C, I have the quantity y minus 3 squared equals 4. Again, draw your line at the equal sign. Now take a moment to look at your equation. Notice you have something squared equals something. Since it's of the format squared equals something, you can use the square root property. So we take the square root of the left side, the square root of the right side, but don't forget about the plus or minus. So on the left side, the square is undone, which leaves us with y minus 3 equals plus or minus square root of 4. Since we introduced the radical, we need to simplify, so we need to factor 4. That gives us y minus 3 equals plus or minus the square root of 2 times 2. Notice we do have a set of 2's, so it comes out of the radical and immediately in front. Now notice we pulled everything out of the radical, so the radical will disappear. What we have now is y minus 3 equals plus or minus 2. Since we still need to solve for the variable, let's isolate it. What needs to happen? Well, we need to add 3 to both sides. Again, when you add the 3, it must be in front. From here, that gives us y equals 3 plus or minus 2. But because we have the plus or minus, we need to separate these. The first would be y equals 3 plus 2. Since 3 plus 2 can be combined, we do need to take the time to do so. And we know 3 plus 2 is 5. Now let's investigate the minus version. That means y equals 3 minus 2. And again, we know 3 minus 2 is 1. So these are your solutions. Here is your try it. Okay, let's see. First, you should have drawn your line. Notice this problem is not of the form something squared equals something, so you have to do some rearranging first. You should have added 20 to both sides. Now that it's in the correct form, we take the square root property and we take the square root of the left side and the right side, but don't forget about the plus or minus. From here, we want to simplify the radical, so you should have done the factor tree of 20. Notice you did have a set of 2's, and you always put it immediately in front of the radical. And you should have x equals plus or minus 2 square root 5. I do want you to take the time to separate this into two separate solutions. Your first one should be x equals positive 2 square root 5. I do want to note the positive sign in front of the 2 is not necessary for your final answer. The second solution would be x equals negative 2 square root 5, and both of those would be your solutions for this problem. D, we have p squared plus 36 equals 0. Again, draw your line at the equal sign. Is this of the correct form where we are ready to use the square root property? No. So we do need to rearrange it. Isolate the square. To do so, we need to subtract 36 on both sides. Now we're ready for the square root property. Take the square root of the left side, the square root of the right side, but don't forget about the plus or minus. Now, what do you notice? Well, the square root and the square undo each other, but on the right side where we have a radical, what do you notice is under the radical? We have a negative. And when you have a negative under the radical, what does that mean? It means you just introduced I. So we now know an I is involved, and we need to simplify 36. So take a moment to factor 36. You should find p equals plus or minus I, and then under the radical you have 2 times 2 and 3 times 3. Notice you do have a set of 2's and a set of 3's, which means everything gets removed from under the radical. So we now have I times 2 times 3. We can clean that up a bit and write that as P equals plus or minus 6I. Again, since we have the plus or minus sign, we do need to separate it. The plus version would give us P equals 6I, a positive 6I. And the negative version would give us P equals a negative 6I. And those would be your solutions. E, we have 7x plus 1 quantity squared equals negative 4. Go ahead and draw your line at the equal sign. Now look at the way this is written. Can we use the square root property on this? Well, let's see. Do we have something squared equals something? Yes, which means we can use the square root property. So what we do is we do take the square root of the left side, the square root of the right side, but don't forget about the plus or minus. So along the left-hand side, the square root and the square undo each other, breaking it free from the radical and exponent. So we now have 7x plus 1 equals plus or minus the square root of negative 4. We're ready to simplify the radical. But first, what do you notice is under the radical? There is a negative, which means what letter just got introduced? I. So I is now involved. We've taken care of the negative. Now we need to factor what's under the radical, which means our equation is now 7x plus 1 equals plus or minus I times the square root of 2 times 2. Now under the radical, notice we do have a set of 2's, which come out immediately in front. And since we've pulled everything out of the radical is now removed. And we have 7x plus 1 equals plus or minus 2I. Now we need to isolate the variable. The first step to isolating x would be to do what? Subtract 1 on both sides. Now when you subtract it, it does matter where it goes. It needs to go immediately in the front, to where we now have negative 1 plus or minus 2I. So we're one step closer to solving for x, but we're not quite there yet. The last thing is the 7 and the x are touching, which implies multiplication. To undo multiplication, we need to divide. When you divide, we divide the left side and the right side. The whole entire right side is divided by 7. Now we're ready to clean this up and see what we really have. On the left side, 7x divided by 7 does give you x. The right side, notice everything is over 7, so we need to separate that. We write it as x equals negative 1 over 7 plus or minus 2I over 7. Now that we still have that plus or minus, we need to separate this. The plus version would give you x equals negative 1 over 7 plus 2 over 7I. Now are those like terms? No. One is a constant, the other is imaginary. Actually, the whole thing is considered a complex number. Now we need to look at the other option, which is the minus version, which would give us x equals negative 1 over 7 minus 2 over 7I, and these would be your solutions.